Today we're going to take a look at lesson number 2 in the exponential functions unit. We're going to look at rational exponents today. Just before we do that though, let's just quickly go over a couple of ones from yesterday, make sure we can do some integral exponents. That means they're whole number ones, right? And so our rules from yesterday, we want to follow BEDMAS. We had 3 rules. We had multiplying bases, we had dividing bases, we had powers of powers. We added the new one about negative exponents. We don't want those. We know we should flip our bases when that happens and the exponent becomes positive. So if I want to try a couple here just to make sure I know what's going on from yesterday, BEDMAS says I should do exponents first. So I need to do this idea out here, power to a power, before I do the multiplying. 3 times 2 will give me negative 6. Okay, so we're going to multiply those. And then I can do my actual multiplying. Base is the same. I can add my exponents and get 9 to the power of 1. And if we try the next one, base is multiplying. That's all I already have there. If I add my exponents, I end up with 5 to the power of negative 4. But we don't like negative exponents, right? So we flip it over, put it on the bottom, and the exponent becomes a positive. And if we try the third one, BEDMAS has brackets first. So inside the bracket on the right-hand side here, I've got dividing. Dividing means I should subtract my exponents. So 2 minus negative 6 will give me an 8. And now I've got bases multiplying. I can add those exponents, and I get 2 to the power of 7. Okay, so that's what we did yesterday. Bases are 4 big rules there, right? Negatives, powers of powers, multiplying bases, and dividing bases. Today we're going to add some new kind of exponents in. We call these rational exponents. By rational, it means our exponents can be a fraction. Okay, specifically, to start here, x to the power of 1 over n. The n we call the nth root. So if it was a 4, it would be the 4th root. If it was a 5, the 5th root, and so on and so on and so on. One way of writing it instead of as a fraction is to actually use something called a radical. A radical is a root sign, and the number on the bottom of the fraction would be our index number. That's this little number right here outside the root sign. I'll write it a little bit bigger so we can see it. N. And our base is x. Okay. I said that's called our root. There are some special names for some of them. If it was a 3, we call that the cube root. If it was a 4, it'd be the 4th root. A 5, the 5th root. 6, the 6th root, and so on and so on. Okay, so if I had something like x to the power of 1/3, I'd write that as x is my base and the cube root. The number on the bottom of the fraction goes in the little check mark part of the root sign. Okay? If you don't see a number, a special case, okay, if it's not indicated, it's always assumed to be a 2. And that makes things a standard square root. So as it shows down here, x to the 1/2 is the same thing as saying the square root of x. Now, if you really wanted to, I wouldn't be against you writing down x to the 1/2 being a base of x and a little 2 out there. That's allowed, but it's not necessary to write the 2. Rational exponents sort of work backwards from regular ones. With a regular exponent, as we apply it, it gets bigger and bigger and bigger, right? So like 3 to the 4 is a big number. 3 times 3 times 3 times 3 is growing. But when I do 3 to the quarter, it would actually get smaller and smaller and smaller. What we're really saying to ourselves here is what number times itself 4 times would come out to that answer. Now that's not a very nice one, it would be a decimal in this case. But if I looked at the next example down here, I see 8 to the 1/3. I'm saying to myself, what number times itself 3 times, so something times something times something, comes out to an answer of 8. Okay, well, the only number that works there is 2 times 2 times 2. So the cube root of 8 is the number 2. Now, yes, you can try these mentally. There's nothing wrong with doing that mentally. However, your calculator may come in handy. On your calculator, you should find a button, probably near the exponent button, whichever one that was, right? One of these buttons, okay? That does the opposite. It should look like, and maybe you have an x there or an n, okay? It could look like that, or maybe it's an n, or a third option. Sometimes people have a button that has x to the 1 over y. You want to find that button if you can, and try this example. And what you'd want to put in your calculator would be, okay, my root, my nth root, that would be 3. And I'm going to press that button, whichever version of this I have, one of these ones, okay? And then 8, and the answer should come out to 2. Okay, just to try that out. And then we'll try some examples how this works. Okay, we're going to write these in radical form. By that I mean I want you to write them with a square root sign before you calculate them, so we understand what's going on here. Okay, so I got 16 to the 1/2. Okay, it's a fraction, which means I have a root sign. My base goes underneath, and the number on the bottom of the fraction goes out there. Now I said 2 is a special one. You don't have to write the 2. That's okay. If you just want to write a root sign, I would accept that. Just writing down this, that's totally fine. And what's the square root of 16? 4. Because 4 times itself twice comes out to 16. Remember, the numbers here should be smaller than they started with. All right, let's try 25 to the 1/2. What would that look like? Well, it's a half, so that means a root sign. Root of 25 is 5. 27 to the 1/3. Okay, my base is 27. My nth root is 3, the part underneath. I use my button on my calculator, so 3 root 27, I get 3. Again, a smaller number. If you're thinking about it, 3 to the power of 3 comes out to 27. That's our objective here. Okay, let's try D. D, I see a negative exponent. Now, negative exponents we know we don't like, so let's deal with a negative exponent right off the bat. How do I deal with it? Same way I would before. I flip my base over. It becomes a positive exponent. And then I do my new idea, my rational exponent idea. I write this as a radical, so with a root sign. Now be careful, you need that 1 over. Let's move this down a little bit here, guys, sorry. Okay, my root sign, my base is 64. The nth root is a 6. Okay, I take my calculator out, the 1 is still on top. The 6th root of 64. What number to the power of 6 comes out to 64? Well, use my calculator. The number is 2. Because 2 to the 6 is 64. All right, let's try the next one. Negative 125 to the power of negative 1/3. I see a negative exponent again. Let's deal with that. Let's flip it over. Okay, and then apply our exponent, or sorry, make our exponent positive. Okay, now what does that mean? I got write it as a radical. 1 over the cube root of 125. Okay. Now the negative sign. The negative sign is not actually attached to the 125. It's not in brackets. So right here, I'm thinking about doing that part first and then taking the negative of it. So this negative can go in front. Okay. It's not in brackets. That means the negative sign is not attached to it. So when I go to do the math now, well, 1 on the top is still 1. The cube root of 125, use my calculator, I end up with 5, and it happens to be negative. Okay. Now if I try the next one, take a look at this one, the cube root of negative 125, the negative sign is in the bracket this time. Okay, what does that mean? When I write this as a radical, underneath the radical I need 125 and the negative sign, because that's my base. And I need the cube root of that. What number times itself 3 times is negative 125? Well, if I use my calculator, I should get negative 5. Okay. So be a little careful with signs. Signs sometimes go underneath the root sign, sometimes they don't. I have to check to see if my brackets are involved, and does that mean I have to include it or not? All right, let's take a look at G, the last one of these. Okay, my exponent's positive, that's good, I like that. My base is negative 16, the whole thing, including the negative sign. I need a root sign, I need a 4. Okay, the 4th root of negative 16. Try my calculator. If I try this on my calculator, I think you're going to get error. Now, why is that? Well, let's think about this question. I want to know some number to the power 4 coming out to a negative. Well, the problem here is our signs, right? When I have the same number 4 times, is there any way that I can ever get that to be a negative? I don't think so, right? If they're all positives, it's positive. If they're all negatives, negative, 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 that would be, well, 2 negatives makes a positive, 2 negatives makes a positive. I get a positive answer. So, a little star here for you, a big idea for you guys. Okay. We cannot take the nth root of a negative base if n, and n is the bottom of your fraction, if n is even. Okay? N in our case is a 4, that's an even number. I can't do negative ones. Okay? Back a second ago, we did one of these up here, we did an nth root, n was 3. I can do that with odd numbers, but I cannot do that with even numbers. Okay, that's one of our big ideas here. Okay, I'm going to pause this now and put the next part in the next video, okay?